Joe Monday, your tutor for this subject. And today's lesson will be the most important part of chapter 1 and 2. So I will ask you to write down to watch and rewatch this video as possible. And what I will ask you is to ask questions on this part. So a PDF will be uploaded on the website, and once it will be uploaded, will be noticed for that. What are the points we are going to discuss? A recall lessons on some small basic, and as well phase sequence. As I said, phase sequence is the most important part of chapter 1 and 2. So you need to master it. And once you master it, what will come next are really easy. So today's video will be based only on the phase sequence, how to draw it. Let's do our recall lessons. Type of phase sequence. From the previous video, we discussed that we have two types of phase sequence. The first one, we call it ABC, known as positive phase sequence, PPS. So a notation of PPS under solving of a problem of example mean positive phase sequence, or when they say ABC, know already that this is a positive phase sequence. The second one, we have CBA, known as negative phase sequence. And we have the notation NPS, just to make it short. When you see NPS, already know that this is your negative phase sequence. When we talk about phase voltage, it means if we are coming from the supply, something like that. You have A, B, C, and the neutral. So if you take your voltmeter and you come to measure the voltage between, let's say, point A and the neutral point, this is your phase voltage as we discussed in the previous video. Okay? But if you come with this voltmeter and then you measure the voltage between A and C, for instance, this will be your line voltage. So for each phase voltage each phase voltage has its own corresponding voltage. So when we talk about the phase voltage AN, which is the same as EA, the corresponding line voltage to the phase voltage A, the corresponding line voltage it's AB. So my phase voltage A, the corresponding line voltage of A is AB. When you talk about phase voltage B, the corresponding voltage is what? Line voltage is PC. When I talk about phase voltage C, the corresponding line voltage is CA. So what does that mean? It means every time I talk about a phase voltage A, I must have a corresponding voltage as AB. For B, the corresponding voltage is BC. And then for C, the corresponding voltage is CA. Phase voltage versus line voltage. As we discussed in our last video, mathematically, the line voltage is equal to square root of 3 of the phase voltage, and therefore, if this is your phase voltage, this is your phase voltage. To change it to a line voltage, you times it by square root of 3. But what happens is they are not gonna have the same angle. So we are going to discuss about the angle in the next part of this lesson. polar coordinate plane. So this is just a revision from let's say high school, but I want you to understand it very well. So first of all, I want you to be focused on this reading. When I say anti-clockwise, we know that we are going to in this direction. So this is our anti-clockwise. So if I start from 0, okay? Therefore, my anti-clockwise direction is going to be what? We have what? Plus, all the angle will be positive because we are going in a anti-clockwise. Our reading of the angle, they are going to be positive. But when it comes to a clockwise direction, it means we are reading our angle in a clockwise direction. So what's going to be the reading of our angle in a clockwise direction? If you are reading our angle in this direction, so when you're reading them in a clockwise direction, you're gonna have negative angle because in the clockwise direction you expect them to be negative. Okay, so the two reading, they are correct. If I have an angle of minus 15 is the same as an angle of 345. The problem is just the reading. You read clockwise and you read anti-clockwise. Okay? Phase sequence, how to draw it? Let's start with the positive phase sequence, which we say it ABC. For clockwise rotation of a shaft, the order is ABC. Winding A peak first, then winding B, then winding C. So as we said, if A is at 0 degree, we expect to have B at 120 because the split between the three conductor is for 120, and this will be at 240. So our shaft, it's basically something like that. So if our A conductor is somewhere here, then we have our B, it's somewhere there, and then our C. So this shaft is rotating in a specific direction. So when it comes to positive phase sequence, A conductor will peak first, then B, then C. And this order will keep repeating itself as long as we continue to rotate this shaft. Okay? So that is our positive phase sequence. So let's take an example. Okay, so from our example, this is an instructions value, we change it to RMS, and therefore our A is the reference is 20. So we know that the split between each, it's always for 120 and then 120. So if A is at 20, which means B will be at 120 minus 120, because we expect our shaft to rotate in a clockwise direction. So in a clockwise direction, angle will be what? Negative. So if A is at 20, the split between each conductor is for 120, then I take 20 minus 120. So I have B at minus 100. If I take C, C is going to be at from minus 120, minus 100 minus 120, then C is going to be at minus 220. And therefore, if we punch it in our calculator, the calculator itself will give us an angle which is going to be lesser than 180. That's what we are expecting. And then from here, we know that our line voltage is what? AB, BC, and CA. So if we take the voltage EA minus AB, because for this case we have AB, so it's going to be A minus B, and therefore we'll get a line voltage of this. Okay, so remember, we say if you take 220, you times it by square root of 3, you will get 381. But the problem is the angle. So when you take EA minus EB, you can see that the line voltage as what? 50. Can you see? The angle between the line and the phase voltage is different. Can you see that? And then you do the same for B. BC is going to be voltage EB minus EC. And then you do the same for CA. And then you're going to get the term. You can see that the magnitude for the line is always bigger than the magnitude of the phase, but they have different angle. Okay, so once you have done that calculation, those calculation, now you can draw your phasor diagram, which is your phase sequence. So you come here. This is the data that we collect from our calculation. Okay, and now we have to draw a phasor diagram according to a positive phase sequence. Positive phase sequence, we see what? We are doing reference to A, B, C. And then ABC, ABC, which is our positive phase sequence, or you can write P, P, S to say that you are doing a phasor diagram of a positive phase sequence. Then you repeat ABC. Why do we repeat ABC? Because of your reference. Okay, because of your reference. So let's say, for instance, our reference is A. What will be next? B. Then the next one is C. Okay, but if our reference is given as B, the next one will be C, then A. If our reference voltage is given as C, the next one will be A to peak, then the next one to peak is going to be B. Okay, so that's why you repeat the notation. Okay, so from the data that we collect, if we draw, you're going to have our EA in our coordinate plane. Polar coordinate is going to be at 20, and then you have your B at minus 100. Okay, because you say B is at minus 100, then minus 100 when you are reading it in a clockwise direction is going to be minus 100. Okay, and then the next one is what? It's C. Then you have your C there. Can you see? So every time that we are given a reference, the three first vector, we put them in a clockwise direction. Okay, but we need to start with a reference, and if the reference is A, we start with A. Then the next one is going to be what? B. After B, then you have what? C. After C, you come back to A. A will pick first, then B, then C. Okay, so after putting the first three, and now we can put our line. You can see that our line AB is at 50. Okay, then at line PC, then line CA. Okay, can you see that? Then we have them in that form. Okay, so what do we observe here? We observe that the split between the line and the phase is for 30 degrees. As you can see, from 20 to 50 you have a split of 30. From 140 to 170 you have a split of 30. From minus 100 to minus 30 you have a split of 30. Okay, so from what we did with a positive phase sequence here, what we observe now is that when drawing the phasor diagram with a positive phase sequence, always start with a reference. Okay, and then the second one, the reference is always 0 unless otherwise stated. So if our reference is not given, we're gonna use 0 degrees as a reference, but in the case that we did, the reference was 20. And then we say the line voltage like the phase voltage are 120 degree apart. Okay, and then the last one, which is really important, in a positive phase sequence system, the line voltage lead the corresponding phase voltage by 30. With a positive phase sequence, the line must always lead their phase. Okay, so if I take, for instance, when I was putting the first three from the reference, I go in a clockwise direction when I have to draw from the reference. Okay, but now the second thing that you have to do is to make sure that the line are leading their corresponding phase voltage. So for instance, when I see A, the corresponding line voltage to A is AB. So therefore AB must lead A. Can you see? To lead it to mean to come before it. Can you see? So I can see A is here, but the line is coming before it, and the speed of it is 30. So if I come, I can see it's B. The corresponding line voltage is BC. So BC must lead B. So you can see that BC is coming before B. The same here, you can see that CA is coming before C, because the corresponding line voltage to C is CA. Okay, so therefore what you have to keep in mind is, when I start with a reference, I must put them in a clockwise direction. After putting my clockwise direction, now I go in a anti-clockwise direction to make sure that my line are leading their corresponding phase. Okay, so this is an example where the reference is a phase voltage. I will do another example when the reference is a line voltage, and then you're gonna make a difference between the two. Let's have a look on a negative phase sequence, which we said CBA. There is no much difference. Now you can see that it's just the order that change. Okay, so for a anti-clock rotation and clockwise direction of the to the shaft, the magnum will pass by the pole pair in a opposite sequence, CBA. CBA to mean that C, the conductor C will pick first, then B will be the second, then the last one will be A, and this will be a repetition. After A, we go back to C, B, A, C, B, A. It's gonna be a repetition, and this will repeat itself until we can stop our shaft. So we take another example as well. As you can see, we want to follow that order. What is the order of the negative phase sequence? C, B, A. Okay, and we say we always go in a clockwise direction. So if you say 20, then you say 20 minus, okay, because every time we are reading in a clockwise direction, our angle must be a negative. So the reference is 20, then you say 20 minus 120, because the split between each conductor is for 120, and then you get EB at minus 100. Then if EB is at minus 100, EA will be at minus 100 minus 120, and then you get this. If you punch it in your calculator, you will get an angle of 140. Okay, and therefore you do your mathematics, because you always going to expect three lines, AB, BC, and CA, and the three will never change. So you take your EA minus EB, therefore you're going to get your EAB at this angle, you do the same. EBC is going to be EB minus EC, and then you do the same to get for CA. Once you have the three voltage, okay, so you collect your data, you go to your phasor diagram. This is our data that we collect. You have our data there. From our data, we have to draw a positive, a negative phase sequence, which is CBA. So CBA is the keyword. Then we can write it as NPS to say that we are drawing a negative phase sequence. So the reason why we repeat it, CBA is to say that if the reference may be changed, in this case, if I set the reference is C, the next one will be what? B, then A. And if the reference change to B, then the next one will be what? A, then you have C. Okay? And if the reference change again, they give us the reference as A. What will come next is C, then you have B. Okay? So from our data, we start with the reference, which is C. Okay? So when we are putting the three first, we always go in a clockwise direction. Okay? And therefore the next one will be what? Because C is the reference, as we say. C is the reference. The next conductor will be B. Okay? Then you say B. If B is next, the next one will be what? A. And then you say A. So don't forget the split between all of them is for 120. After that, now you put your line. You can see that CA is there, BC is there, and then AB. And we observe again what? We observe that the split between the line and the phase and its corresponding line is for 30 degrees. Okay? The same as for the positive phase sequence. The split is always different, but we're going to observe the difference between the two is the notes that we are going to take. When we are drawing a phasor diagram for the negative phase sequence, we observe that the difference, we always start with a reference. If it's not given, the angle will be 0. And then the line, they're always apart, as we said for the positive phase sequence. But look at the difference now. Now we observe that the line voltage lag their corresponding phase voltage by 30. Okay? So when I come here, I can see that after placing my three conductor, I can see that this is in a clockwise direction. Okay, when you are reading, just to put the first three. Okay, so you start with C, the next one is B, as we said, the next one is gonna be A, and then the next one will be C, and it's a repetition like that. So when it comes to your line voltage, you can see that the split is for 30. Okay, the split between this and this is 30, the split between that and that is 30, the split between this and this is 30. Okay, so once we observe that the split is 30, how do we know that if our line are lagging their phase? So you'd see CA, the corresponding phase is C. So when I'm reading them in a anti-clockwise direction, I will see that CA is lagging C. It means it's coming behind C. When I come here, I see AB, the corresponding phase is A. So I can see A is lagging A. AB is lagging A. It's coming behind A. If I come here, I can see BC, the corresponding phase is B, and therefore I can see that BC is lagging B. Okay, so that basically the difference between the positive and the negative sequence is that the positive phase sequence, the line lead the phase. The negative phase sequence, the line legs the phase for 30 degrees. Okay, so I will do 2 examples for you to understand how to draw it, because this is just an explanation where I make it big, long for you to understand. So let's say, for instance, you have to do a to solve a problem or during the test. How do you draw them without going this long step? Okay, you will see it now.